focus our attention on soil and climate, and we're going to start with a grazing from Jeff Creek, who is the director of the Carbon Cycle Institute in California. So this continues our theme of trying to make connections, and one of the connections we're making is the cross-country connection that we have with our friends and partners in California that are doing things that we're aspiring to do out here in New England, and some of us are doing it on a kind of individual and community basis. But what we're finding is that the Carbon Cycle Institute is finding ways to do it on a policy level in California to great success. So I'm very happy to welcome Jeff Creek. Welcome, Jeff.
Thanks, Matt. Let's see, which is, yeah, okay. Thank you, great to be here. Thanks, Matt, for the invitation. I'm going to do a very, very quick and a very high level overview of kind of the, maybe the theory behind what we're doing. And when I say we, I mean all of us in this room, actually, because I think there's, we often get deep into the weeds on the mechanics of the kinds of things we talked about this morning. But I, from my understanding, needed at some point in my own education to step way back and say, what are we talking about? What's really this about? And the Marine Carbon Project for me has been a huge part of that understanding. So I'm going to throw this up as an idea that carbon can be and should be and needs to be, particularly in light of the climate crisis, and the organizing principle around which we organize our ecosystem management thinking. Move. All right, so here's a quote out of a paper by Jansen, which I think kind of sums it up. Most of the solar energy invested in carbon by plants on land ends up in the soil. Managing soil, therefore, means managing energy. This perspective expands our view well beyond carbon sequestration and frames soil as a mediator of energy flows, and the quote by Leopold, probably most of you are familiar with. This idea is, this is not an abstraction. We're talking about the reality of the transfer of solar energy through the process of photosynthesis to the soil, and from which then all ecosystem processes are supported. So I find this language very helpful. The concept of negative and positive feedbacks, we use those terms all the time. We don't necessarily know what we're talking about when we say that. But I would suggest that systems, ecosystems, human systems, however we want to talk about systems, are in one of two states at all times. They're either changing or they're staying the same. Very simple idea. And system equilibrium is fundamentally maintained through negative feedback processes, that is, deviation dampening processes. So you see that squiggly line modulating around a central tendency, right? So the system tends to oscillate around that and maintains itself at some degree of equilibrium. On the other hand, system change is driven by positive feedbacks, which are deviation amplifying processes, where you start maybe a system's at equilibrium, some change in system dynamics occurs, the system goes through a trajectory of change, and then perhaps at some point on the other end ends up at a different equilibrial state. And that could be at a higher level of organization and energy, or a lower level of organization and energy. The classic example, of course, of a negative feedback is a thermostat. The room warms up, thermostat turns off the heat, the room begins to cool down, thermostat turns on the heat, and so it's this fluctuation actually that keeps the room at a comfortable temperature. On the other hand, we see positive feedbacks now playing themselves out at the global scale, as exemplified in what's happening in the Arctic, where global warming has driven melting of Arctic ice, exposing more dark water at the North Pole. Of course, dark water heats more readily than reflective ice, so Arctic water is warming, driving more additional melting, exposing more dark water, driving more warming, driving additional melting, and so you begin to see a runaway positive feedback driving systemic change. CO2 Curve, I'm sure most of you are aware or familiar with this. This is the record of carbon dioxide in the atmosphere since records began in around 1954 or so. The point I want to make here is how quickly this is changing, how quickly we are seeing this process of positive feedbacks driving atmospheric change. Up in the corner is 2 years of record. That horizontal line starts on the left where we were 2 years ago. You can see where we are today. This is a very dramatic shift. But what's interesting here is it's actually two things going on. We have an equilibrial system fluctuating around that deeply rising curve, right? So technically that line should be horizontal, and we'd see this fluctuating system, which is the interannual flux of carbon dioxide in the atmosphere, and everything would be hunky-dory. But instead, because of our fossil fuel emissions, we're bending that curve upward, which in turn is driving additional emissions from things like melting permafrost, for example. But what's really important in thinking about positive feedbacks and system change is this potential for systems, for that process to work in both directions. So we can think about positive feedbacks that lead to negative system change, such as we're seeing at the global scale now, or we can think about positive feedbacks leading to positive system change. So this process works in both directions. Historically, we have managed for what we call tolerable, the T factor, tolerable soil losses. This came out of the Dust Bowl era, where soil losses were so extreme, we had to think about, let's put a stop to that. What's the maximum amount of soil we could lose from an acre of ground on an ongoing annual basis and still sustain agricultural productivity? We came up with an average acceptable soil loss of about 4 tons to the acre per year, tolerable soil loss. What are we managing for when we manage for tolerable soil loss? We're managing for equilibrium, trying to keep the system at a steady state of production. Is that a wise decision given the level of degradation we had experienced up to this point in time? And I don't think so. I don't think, and the Soil Conservation Service didn't think so after time, and suggested, well, maybe we should be managing for change. And how would we manage for change in our soil systems? Maybe if we think about this C factor, if we start managing for soil carbon, soil organic matter, maybe we can begin to drive a trajectory of change. And here in this slide, they've even put a dollar value on that, this is 2011 dollars, so you can imagine it's much greater. What's interesting is this is data from, this is model data based on the Marine Carbon Project results. And what was exciting for me when I saw this figure when Becca Rouse published this in 2015 was I immediately recognized that rising curve, not the hockey stick curve, which is a compost decay curve. So we applied compost to our grazed grasslands in Marin County, year 1, and then we see the compost decaying over time. But the response of the ecosystem in the background to that one-time application of carbon, or that is to say energy, as compost to that system. And you see that rising curve following a classic homeoretic or positive feedback pattern, which is the ecosystem response to that one-time application of compost. So what's going on there? The compost induced additional photosynthetic capture of carbon from the atmosphere that's increased plant productivity, driving additional capture of carbon, sequestration of carbon in the soil, driving, in the subsequent years, additional plant growth, additional capture of carbon, driving increased water holding capacity in the soil, driving additional plant growth, and that rising curve is building on itself over time. The model suggests that will continue for 40 or 50 years from a single one-time application of additional solar energy going into the system in the form of compost. When we think about systems, it's critical we get our boundaries right. And this came up for me this morning as I was thinking about borders and international borders. I think the same concepts kind of apply. If we draw our boundaries, and this is from a recent paper by Stanley et al., looking at the greenhouse gas emissions from 2 different types of livestock finishing systems. One, an adaptive multi-paddock grazing system, and one, a feedlot system. And for those of us that are excited by the idea of grass-fed beef, this is a rather disturbing graph, because if you look at it, you realize, first of all, both systems are emitters of greenhouse gases, according to this data. And the adaptive multi-paddock grazing system is actually emitting much more net greenhouse gases than the feedlot system, which in the paper is attributed to efficiencies associated with feedlot agriculture. So that's drawing the boundary around those 2 systems in that way. If we actually, however, include the soil in that analysis, suddenly the multi-paddock system emerges as not only preferable to the feedlot system, but also a net greenhouse gas sink. So when you think about life cycle assessments, you really need to think very hard about where you're drawing the line around that system. This is a little bit complicated, but what I'm trying to show here is two different things. On the bottom, we have a record of carbon dioxide in the atmosphere based on ice cores. The inset there from Sanderman et al.'s recent paper is carbon dioxide in the atmosphere over time, okay? And it's essentially Sanderman et al. Are making the connection between human land use and CO2 levels in the atmosphere. So, and they go back 10,000 years to a point they could say no land use. So that is, what they mean, of course, is there's no significant human impact on carbon emissions going, if we go back 10,000 years. But if you look at the ice core record on the bottom, about, maybe 7,000 years ago, that CO2 curve starts to rise. And there's a steadily rising line of CO2 in the atmosphere going back that far, which we can pretty much correlate with the intensification of human use of the biosphere, or agriculture, and the use of fire, for example. And that correlates very nicely with Sanderman's data. And then suddenly in the what we might call the more modern period, we have this dramatic rise of CO2. Very interesting, as a little, and I put up disturbance there in quotes with question mark, because disturbance, or event, you might say, something has to happen for the system to change, right? So these points of inflection in the curve are points where we can probably reasonably assume something happened. There's a little deep dip in the CO2 levels in the atmosphere on the far right side, just before we enter the modern era and this enormous dramatic shift. There's a decline in CO2 in the atmosphere. And I've been looking at that for quite some time and not giving it a whole lot of credence. I thought, well, that's the little ice age, something happened there. And recently, in fact, just February this year, Koch et al. Published a very interesting paper in which they suggested that decline in CO2 in the atmosphere correlates very neatly with European contact with the Americas. And that when Europeans came to the Americas and subsequently decimated the human population of the Americas, literally decimated. There were about 10% of the population was left after the first 150 years or so. There was a wholesale abandonment of working landscapes in the Americas because of the loss of human population. And that led to the massive reforestation of what had been human-managed landscapes. And that correlated with this drawdown of CO2 from the atmosphere. That also correlates with a little ice age, Northern Europe, where we had dramatic reductions in grain production and starvation. And then, of course, we entered the modern era and things go completely out of control. But I put this up just because it gives you a sense of maybe just how complicated our relationship with the biosphere has been for a very long time. So I also used the term disturbance in the previous slide because I'd like to suggest, as many others have before me, that it's really through the manipulation and management of disturbance that we manage ecosystem dynamics. We manage energy dynamics of ecosystems. And so here's an example of really a disturbing, intentional disturbance of a grassland system. This happens to be Marin County, in which maybe 200,000 pounds of beef has been put into a tight paddock cell, and they'll be there, I think, for all of 2 hours. So what do we mean when we talk about managing disturbance in the context of livestock agriculture, or grazing particularly? We're really talking about managing the space, the time, the magnitude, and the frequency of that disturbance. And we can translate that into the amount of land area, the amount of time the animals are on, the number or perhaps the weight of the animals, and then how much time passes before livestock are brought back to that particular piece of the landscape. So I would suggest in the context of this meeting today that we can use livestock, which are a particularly powerful biotic factor, to paraphrase Tansley, to initiate these deviation amplifying processes, to drive positive feedbacks, to capture additional solar energy and ecosystem carbon to move our systems in the direction we want them to go. And I think it's a very simple concept that we can apply at almost any scale when we're talking about ecosystem management. And ultimately, using that understanding and those processes to actually bend that rising CO2 curve in the other direction by simply lengthening that interannual flux, that annual drawdown that happens every year when the Northern Hemisphere forests leaf out, as they're doing right now outside, drawing down that 6 parts per million of CO2 from the atmosphere. Just lengthen that curve just a little more by managing for additional carbon capture from the atmosphere. And we could actually imagine beginning to bend that curve. So I'll stop there.
So I'm going to welcome the panel up, and I'll introduce them as they walk up. Yeah. So Nico will manage our. So what we have is Nicole Blackstone, who is assistant professor in the Division of Agriculture, Food, and Environment at Tufts University. I found her actually down at UNH, right, as a fellow before then. And then, so not everybody's going to come? Yeah, come on up. Yeah. So Caitlin Preece is my colleague in biological sciences here at Dartmouth. And both of our children are otters. And then Leslie-Anne Dipigny-Giraud is the geographer in geography at University of Vermont, but I think also extremely important, she's the state climatologist for Vermont, and that's the way I discovered her. She was on VPR Dropping Science, and I said, I have to have her in this conference, and so that's how I presented it to her. And so we're super excited to have Leslie-Anne today.
No pressure.
And she's in fact not just, of course, just not studying Vermont, but part of a national study that's in its 4th iteration. So her knowledge is deep. And so my old friend Nico Horster will manage, right? He's our one.
Yeah. Thank you, Matt, for the introduction. I would like to give the 3 ladies on the panel an opportunity to introduce themselves. Jeff sort of did a little bit of that by opening up setting the stage for this conversation that we're having. So would you like to go first and introduce yourself, sort of speak about who you are, what your line of work is, and how it relates to what we're talking today? That'd be wonderful.
Yeah, I'm pretty loud, but I'll use the mic anyway. Okay. I'm Nicole Tichenor Blackstone. I'm an assistant professor at Tufts. I would classify myself as a food systems scientist. So I do interdisciplinary research at the nexus of environmental science, agricultural science, nutrition, and health. And so I come at this work from those angles. I also have a humanities background, and as an undergraduate, I was a philosophy of religion major, so I sort of see this from a lot of different angles. And I believe I was invited here today because I've done research on our regional food system here in New England and in the greater Northeast. So specifically as part of my dissertation work, I worked with grass-fed beef producers and dairy beef producers here in the region to understand the life cycle environmental consequences of their production systems. So I'm happy to share my findings from some of that work today. And I also sort of bring a food systems lens. So in addition to thinking about the supply side of things, I'm also thinking about kind of the consumption and equity sides of things. I was really excited by the panel discussion that we had this morning on labor. And I'm also thinking about this in terms of beef and consumption equity in this country and globally. So I'm happy to contribute those perspectives as well to the conversation. And I'll leave it there for now.
So I'm Kahlan Hicks. I'm an assistant professor here at Dartmouth. My specialty is soils. So I would call myself a soil biogeochemist / ecosystem ecologist. My research has really focused on how soils are responding to climate change, what that means in terms of positive and negative feedback. So I love the way that Jeff focused his talk on those feedbacks. I have mostly worked in forest, permafrost, and recently started working in grassland systems. And one of the projects I'm starting here at Dartmouth is to try to replicate the research that Jeff showed about Becker Riles' research for the Marin Carbon Project here on old fields in New England, to see if compost additions here in New England will lead to the same positive effects that we're seeing in California. So I bring a real soil carbon nitty-gritty perspective to this, thinking about soil carbon stabilization, how long will it last in the soils, that sort of thing. I'm happy to answer any technical questions people might have about soil carbon and how it works. And also hopefully to give a more broad perspective, not just of grazing ecosystems, but of all different sorts of land use. All right.
Thank you.
So I'm Leslie Giroux. My background is in applied hydroclimatology. I'm a professor at University of Vermont in the Geography Department. And my focus primarily is on land surface processes, which is how the atmosphere influences what's taking place on the land. And I'm particularly grateful to Matt for inviting me on this panel, because it's caused me to stretch a little bit. When I think about the work that I've done in terms of agriculture, is primarily on the vegetation side of things, so droughts and floods and how those affect plants and plant relationships. And so I didn't know that much about bovine and ruminants and all of those pieces of agriculture, so I thank you for the invitation to come and learn a little bit more and sort of delve a little bit deeper. It also helped me to realize that putting on my hat as the lead author for the Northeast chapter for the National Climate Assessment, that we did not delve as deeply into livestock and the animal side of agriculture as we could have. And I'm not sure if that is part of a gap in the literature, if it's an opportunity for the next 4 years to actually get some of the amazing work that's taking place around the region into either state reports and or peer-reviewed literature. So I'm going to throw that out before I forget about it. And it's been a very eye-opening experience to bring those pieces of what I do in my usual life, which is sort of teaching and working with state agencies, together with how do we sort of take a step back and look broadly in bringing this to the fore, and some of the things that we can use that we know as scientists to help change policy.
Thank you so much. I would like to start off talking a little bit, and maybe we'll start with Caitlin on that, is explain sort of the slightly nerdy part of this, is what is actually happening. When we opened the discussion or conversation this morning, we talked a little bit about how we use our cattle to harvest the top 30% of the grass, because that's where the sugar is. So it all starts with photosynthesis, and that's producing sugar. And so maybe we can take it from there and sort of tie it down underground and what actually happens there. So we all have a common ground. We're talking about what the theory is, what's happening, and that this is relatively new insights, actually.
Okay, so yeah. So it all starts with the plants, and they're photosynthesizing. They're getting they're getting carbon out of the atmosphere. And then the plants are depositing that in soils in two ways: through their roots and the root biomass. They can also exudate sugars and organic acids from the roots into the soils. And then also, when those plants die in the fall here, then that litter goes onto the ground. Anything that hasn't been harvested or eaten by cows will go onto the ground, and that litter will then get incorporated into the soil carbon pool as well. So anytime plants are growing, anything that once they're dead, any of that material that hasn't been consumed by cows will then become part of the soil organic carbon pool. So anything that increases plant growth can increase soil carbon storage. And so grazing systems have been evolved for the plants to actually increase their growth as a result of animals grazing. So the grass is like, oh no, we've lost some of our carbon, we need to build up again. And so anytime they're grazed, as long as they're not overgrazed to a point where they can't start photosynthesizing again, it will actually increase the amount of production, the amount of photosynthesis that happens, which then increases the amount of carbon that will go into the soil. That's one way grazing systems can help increase carbon storage in soils. The second way is that the cows are also inputting carbon into the soils through their manure. So that is carbon that goes back to the system, but most importantly, it's also concentrated in nutrients. And those nutrients feed the plants, and that allows the plants to photosynthesize more, thereby pumping more carbon into the ground. So increasing carbon storage that way. And I could get into more details, but maybe that's good.
Yeah, I think that's a great start. Thank you. I maybe want to add one or two tiny little points to that, and the sort of the ideas that we're utilizing a natural biological cycle here, and that the ruminants that are grazing are bioaccelerators in a managed system. They will speed up the biology that is naturally occurring, which would be one growth cycle to seed, and then a dying off of the plant in the fall. But by keeping the plants in vegetative growth, we're forcing them to actually do more than they would naturally do. And the cattle do that work for us. And so if any of you want to tie this into the biology, I think that is a really crucial part that unfortunately in soil research has only in the last decade really come to the foreground, is that the experiments in universities were all done with sterilized soil. And so nothing was really working because there was no biology. So now we have biology that's in the mix.
Can I add something to that? Yeah, so in the past decade, what we found with soils is that we need healthy microbial communities in order to store carbon in soils. And so if you just had a sterile soil, that the carbon doesn't get incorporated into the soil as well. You need the microbes, the fungi and bacteria inside the soil to be feeding on this plant-derived and manure-derived organic matter. And as they feed on it, and they die, the dead bodies of the microbes and fungi then get stuck to the soil particles, to the soil minerals, and that allows that carbon to be stored for a longer amount of time. And so having a really healthy biome as part of your soil is really integral to this process of increasing carbon storage.
Thank you. And I think this is really whether the rubber meets the road, proverbially speaking, in that there's a lot of carbon activity happening that is very volatile and very dependent on the minute of sunlight that has happened before, or the 10 minutes that have happened before. And so how does this transition from liquid carbon to stable carbon actually happen? And that is where it gets sticky, right? Because we don't really have good measurements for that. The science is really new, and if any of you want to delve a little bit more into that quagmire of how do we measure this so it actually becomes a benefit that is measurable, because without measurement we're going to be hard pressed to get paid for it as farmers.
Okay, so to actually measure, you're saying the sticky carbon that is stuck onto minerals?
Right.
Yeah, that's the stuff that will stay long term. And I will say, so a lot of you, if you have these systems, you're measuring carbon in the soils, you're sending it off to a soil testing facility, what you're getting is the percent carbon, right? So you're just getting one number, and it's from that you can't really tell if you have this sticky carbon or not. And it's hotly debated in the scientific community how best to measure that. I have my preferences. So you can look at aggregates, and it's very important in grassland systems to look at the aggregation of your soil. And so the more of these smaller aggregates you have, the longer the carbon will stay in your soils, the more stable it is. And so the way to do that is, I guess you could send it off to a facility. I don't know, are there testing facilities that will now look at aggregates? Or is this something that you need a university for? But you basically just sieve the soil through sieves of increasingly small sizes to get what's in these different aggregate classes. The method that I use, which is to use density fractionation. And so you basically take your soil and you put it in a really dense salty solution. And what comes to the top, what floats, is the more easily decomposable carbon that's not going to stick around. And the stuff that settles to the bottom is associated with minerals, and it's heavy, and it's going to stick around for a longer period of time. But it's not an easy measurement to make, so I think that is a really big challenge in terms of how can we make this on a large scale to help inform land managers about their practices.
Right. So, Liz-Ann, why does this matter?
Why does it matter?
Why does it matter? Why do we care about the carbon in the soil? If you want to sort of I'm trying to sort of tie your work of the climate as a big topic back to what we as practical agriculturists can affect.
So I think it matters from a number of different perspectives. I think Jeff had two words in his introductory remarks that really summed this out. Systems was one big piece and feedback was the other big piece. And I think once you look at those and you look at how they either amplify or dampen the entire process, that's one part of the thing. The other thing that I think is also important is if you look at it from a systems perspective, it matters because you need to bring some of the other gases into the equation, things like methane. I think we spend a lot of time looking at carbon dioxide and nitrous oxide and all of those, but we also need to remember that some of the stuff that our animals emit is methane, and methane has a really, really powerful greenhouse warming effect. And so systems, if we go back to that, it matters because we need to have all of the players looking at to see what the contributions are and how they're increasing and how they interact with each other.
Mm-hmm. Thank you. Thanks for bringing up methane. That is the proverbial red flag for me as a farmer. How much studies, and this sort of gets maybe into a little bit more of the environmental larger picture, are there actually replicating natural systems in the studies? I've read a lot of studies on grazing, and they all suck, basically, to put it very bluntly. There are very few people who actually take the systems that we've seen in the slide where you have 200,000 pounds in an acre for 2 hours, and they take 2 steers and put them on an acre, and they put 1 steer on an acre in the field next to them, and they say, well, we have twice the impact here, what's the difference? Well, nothing, right? Because it's actually about the absolute impact, not the relative one. And so I would like to hear from those of you who are in the universities. I know, Jeff, you already know what's going on there. Are we studying what's happening to methane in the natural system where there's methane digesting bacteria right where the cattle is, rather than where in a feedlot where they aren't there? Are we looking at how these natural systems are actually working? I often feel like we're so abstract that we forget about the actual biology in situ.
Okay. So I'm thinking in terms of methane. Obviously, there's more methanotrophs. There's bacteria in the soil that will actually consume methane, right? And so if you're in a feedlot and all that manure is going into a massive pile, that's not going to happen. These methanotrophs need oxygen. And so if the manure is then falling on a soil that has a low bulk density, so it's not overly trampled, so we don't have like a high number of cattle there, it's like a little bit of a lower impact, there will be methanotrophs in that soil that will be able to consume some of the methane produced. I actually don't know what proportion of that methane, though, gets consumed by the soil versus flux to the atmosphere. I don't have a good idea of
It's
that.
an interesting question because arguably we had more ruminants in prehistoric times on this planet than we have now, and we didn't see the climate impacts that we're now blaming on methane. Yeah. So it's a really large, deep question because methane is a problem if it gets out there.
Yeah, but from a life cycle perspective, as we know, the major source of methane emissions from a ruminant system is not coming out. It's not soil-based, it's animal-based, right? And I've actually done work in this region, and I will say we definitely need more long-term trials using real farming systems to understand over time how much soil C we can actually sequester over long time periods. So if anybody works for a foundation in this room and would like to fund long-term ecological research on soil carbon sequestration and grazing, that would be great. But so in my work, I did one of these life cycle analyses that Jeff put up on the board that Paige Stanley did in Michigan, focused on grass-fed beef in this region. And when you add up the gases that are being emitted in a management-intensive grazing system in this region versus a admittedly possibly conservative, but the best available data that I had at the time, sequestration rate for this system. This would be a grass-fed system where animals are slaughtered 20 would be really soon, maybe 24 months. 24 months of age. They're moved really frequently on the landscape. They're fed forage for a significant fraction of the year because it's cold here, and we have to do that. We can't graze year round. But even when accounting for decent sequestration, there are still net emissions coming out of those systems, whether I wanted to see those results or not. And in that scenario where we accounted for sequestration, the grass-fed system effectively got to about on par with a feedlot system, which is hard to say out loud at this conference, in the Northeast. The comparison to Stanley's paper, in terms of system boundaries, so we looked at the whole life cycle of the animals, including the fraction of the herd that's required to finish a calf to go from birth to death in a system, and all of the inputs, et cetera, that go into that system. Paige Stanley's paper, they only looked at the finishing system, and they were clear, they're just looking at finishing systems, but actually the greenhouse gas emissions from beef tend to be 60-ish% come from the breeding herd, not the actual finishing system. So I really admire the work that they're doing at Michigan State, and I would be really curious to see what happens if they expand that system boundary to look at the whole life cycle of the animal, because if they are getting those kinds of results for the whole life cycle of the animal, then that's actually really exciting. And Caitlin, you can comment on this. I would think the conditions that they experience in Michigan would be similar kind of climate and soil conditions that we would have here, and so maybe we can learn from what's happening in Michigan and point to those production systems as kind of things to shoot for. But the data that I've seen to here doesn't point to being net zero or anywhere close to net zero for our grass-fed systems here. But we need more long-term soils data. So.
Yeah, that was a really good point about context matters, and a lot of the research that's been done recently on this is coming out of the Marine Carbon Project, which is just phenomenal. But California is a really different system than here. In meta-analyses where scientists have looked at multiple studies of the effects of grazing on soil carbon, what they've found is that it's really context and climate dependent. And so generally in areas that are wetter, they're not seeing the same benefits in terms of soil carbon storage as they see in drier ecosystems. And so compared to California, where they've seen these massive benefits, we are definitely a wetter ecosystem, and more work needs to be done in wetter ecosystems to see if we can get that same effect. So one of the reasons, Jeff had posted that great graph that showed that new equilibrium happening with the compost addition in the Marine Carbon Project. And I actually recently was at a conference where I met a graduate student taking those data and running them through different climate simulations. And the #1 determinant of how long that carbon stayed in the ground was soil moisture. And so in the moisture that they saw in California, it was staying in the ground, but once they got it into a wetter system, it was disappearing after about 40 years. And so, but that was a single application. Can we maintain that higher equilibrium with multiple applications?
Yeah, and the point I was trying to make in my slide presentation was that we understand the basic principles driving these systems. And if we choose to manage accordingly, and it will be different for every system, we have the potential to be achieving our objectives, our greenhouse gas objectives specifically. So maybe to Nico's point, taking data from a single situation or experimental research context, including the Marine Carbon Project, and trying to transfer that into a different ecology and expecting the same result, or just being surprised that you don't get the same result, it shouldn't be a surprise. That these are very system-specific processes, and so when we take grazing, which by the way has no definition, right? I mean, when we say grazing, we don't even have there isn't an agreed definition for grazing. So, is grazing good? it's a meaningless question. So we really, I mean, this is why I devolved to this very high level way of talking about this stuff, because we really need to be getting down to the brass tacks of what are we talking about, and be really clear in our definitions. So I would caution all of us, you know, when we talk to folks we don't necessarily have a shared language with about these processes, it's worth taking a little time to define the terms we think we're understanding, because most of the time I find, and I've been at this question for a very long time, most of the time we're not talking about the same thing. So, what that's worth.
Yeah.
So I'm going to follow up on that from a slightly outsider perspective, and echoing exactly everything that's gone before, and pose a question to Matt. Is there going to be like a white paper that comes out of all of these various panel discussions and brainstorms in terms of where things are right now and how we can move forward in sort of capturing all of the essence and knowledge that's in this room?
So we're going to have breakout sessions right after this. They're going to be documented, they're going to be transcribed, and they're going to move forward both in terms of Melanie's conference at ACE and also Food Solutions New England has their annual summit in 2020 in the spring. So that will continue. Whether a white paper comes out of it, that will be up to maybe the collective minds in the room that might have the resources to do that. So it's a potential. There's a will, there's a way. I know that there's funding, but that's another issue.
Yeah, because I think it's just amazing that there's so much brain power in this room and so many shared experiences, but there's a lot of transdisciplinary pieces that we need to sort of make sure that we're all crossing effectively, and I think this is like a golden opportunity to kind of capture and sort of build on that. So I just want to throw that out there.
Thank you very much. Yeah, please go ahead.
Nico, I just wanted to honor what your comment about methane, having your hair bristle when someone talks about methane, because I think farms get demonized for it. But we wouldn't be having the conversation about the levels of anthropogenic greenhouse gas emissions from ruminants that we are having if we didn't eat so much in particular countries, if we didn't consume so much beef. So for example, in this country, and as we've talked about, it's not this sort of regenerative agriculture style beef that most people are consuming. We're consuming about 27 kilograms per capita per year of beef in this country. The global average is 6 or 4 kilograms per capita per year. So we're consuming 4 times as much beef as the global average, and over twice as much beef as the EU countries combined, or on average. So thinking about, we've talked about how our systems are out of balance. And so, even if there were slightly higher greenhouse gas emissions in a grass-fed system, it would matter a lot less if we were consuming a lot less and we were valuing what we consume and paying for that value. So I just want to throw that out there as part of the conversation. I know there's going to be a whole additional conference talking about the consumption side of this, but I don't think we can talk about the production side without the consumption side.
Yeah, I appreciate your comment and I completely disagree. But since I'm running the panel, I'm going to refrain from going there too deeply. But the issue is tillage. The issue is tillage and fossil fuel consumption in growing crops. It's not the animals.
So yeah, I mean, if you look at the effect that land use has on, then I'm not thinking about the methane, but I'm not thinking from a life cycle perspective, from a soil carbon perspective. The best use for land is here would be forests in terms of soil carbon, and then grazing, and then tilled agriculture is way at the bottom.
Yeah,
so it's definitely going to be a
geographically
much.
Speaking, already the geography of our landscape here doesn't lend itself to tillage.
No, but you're right. But so many rocks. I found one place without rocks to do research. It's hard as a soil scientist around here. The rocks, oh, they're brutal. Yeah. No, but it's definitely, if you think in terms of agricultural land use, a great grazing system, which we don't have a good definition of, is definitely better than intensive agriculture from a soil carbon perspective.
Yes.
And then from a life cycle analysis, though, in terms of the amount of fossil fuels that go into the equipment to run those systems, I'd be curious about that as well.
Well, I think that's really the big elephant in the room, is that we're not talking about all the soy and corn that gets grown to feed hogs and chickens. And yes, a very small percentage goes to beef, but the vast majority for the meat production goes into pigs and fowl. And that's where the real issue is, because every time you till, you're going to destroy the carbon structure and release that. 40% of the carbon that's in the atmosphere comes from agriculture originally. So we know already that we have screwed the system up by using agricultural practices. And so maybe, Leslie, it will be great to tie this in. Why do we care about the carbon in the soil? What are the benefits of the carbon in the soil? So we talked about drawing that into the soil, which is great. We know we have too much carbon out there in the air, so we want it back where it originally came from. So how we get there, we know there's a lot of questions, there's a lot of new paths, and hopefully there's going to be some research, but what does it actually do in the soil? Climate speaking wise, looking at water cycles and retention and slowing down system procedures and stuff like that.
This is so important. Like, I had notes for today, and I just wrote this over and over, and it's more than just carbon. So we can talk about the life cycle analysis. We can talk about, is it going to be a net zero, or is it going to actually help mitigate climate change by sequestering carbon? That's a question, but there is no doubt that increasing the carbon in your soil will make a healthier soil, will increase water storage, will increase the ability to retain water, to retain nutrients, will help plant growth. There's no question of the science behind it. So even if we can't justify increasing soil carbon from a greenhouse gas perspective, it can be justified from a soil health perspective.
And just to echo that, if you capture it in the soil, that means it's not going to be captured as much in the oceans, which open up a different kind of worms, because once you start capturing carbon in the oceans and you start changing the heat content, and that then has a ripple effect with things like hurricanes and other types of cyclones, it makes more sense to capture it in the soil itself.
Yeah, and maybe it's redundant, but I'd just go back to that quote from Jansen and the quote from Leopold, that all of our ecologies run on solar energy. That's what they do. And that energy enters the system through the photosynthesizing plant and ultimately ends up in the soil. So that soil is a driver of system biodiversity, system function, including hydrology. And so it's really, we have ignored it because you basically can't see it unless you're a scientist willing to go out there and dig holes. But we've reached a point where we continue to ignore it at our peril. And so I think it behooves us to think very long and hard about soil carbon and its role, as Nico's question suggests. We really need to be thinking about that very hard.
Great. I would like to see if there are questions out in the audience, or yes? Yes. 1, 2, 3.
Okay.
Henry, and then here.
Okay. Oh, did I miss one? Oh, yeah, okay. The environmental science.
So I just want to, because one of the things that people talk about when they talk about cows and pollution is they talk about non-point source pollution, which is a whole other thing. And when you talk about regenerative agriculture, you're talking about having the cows out on the pasture pooping there. And before there was the climate change issue, there was the non-point source pollution issue. And they created a very capital-intensive system in order to deal with that, particularly in dairy, with the those large capital-intensive manure systems that kept all the manure in a spot. And if you were really investing a lot of money in it, you could actually create energy from that. And there's a lot of farmers who have been either have done or have been forced to invest in those systems. And that's kind of, and there's a certain group of environmentalists called eco-modernists who believe that if we sort of intensify our technology, that this is the way to go, and that they kind of support those kinds of systems as the way to deal with are environmental problems that have to do with livestock agriculture. And I wondered if, are you in conversation with those folks and those solutions, and what kinds of conversations do you have with those folks?
Yeah, so I mentioned I use the tool of lifecycle analysis in my work, and something that people who, many practitioners I would say who use lifecycle analysis don't understand the limitations of the tool. And one of the limitations of the tool is that it cannot account for example, spatial concentration of nutrients in the environment. So even if you have when you have a high output system, like a dairy or, for example, a dairy beef operation where there may be a lot of corn-based feed coming into the system, the animals are finished quickly or they're very highly productive, and so per unit output, per unit meat or per unit milk, the potential water quality impacts or other kind of local and regional pollutant impacts look smaller compared to an extensive system. But what that doesn't recognize is that there's a spatial component because you are concentrating nutrients in the environment. And there are ways to deal with this when you do life cycle analysis to contextualize your results, but it's often not done, and I think misleading conclusions are drawn, particularly on the nutrient side of things, with things like very intensive dairy or very intensive beef production systems. So I think there's actually an ongoing conversation in the practitioner community about how we improve methods to deal with those kinds of issues in agriculture, because this is a tool that was originally developed for use in factories, for like how do we measure the ecological efficiency of a factory, and then over the last 20 years we started applying it to agriculture, which is much more complicated than a manufacturing plant. So I think from a scientific perspective there are advances, but there are definitely limitations, and if you see results like that, you should be skeptical, particularly on the nutrient side of things.
Just to clarify, so you're saying that with those analyses, the more intensive practices looked like they were better from a nutrient standpoint? Okay.
Because they're like per unit of beef produced or per gallon of milk produced, because they're so productive.
I see.
Right, not by acre.
Not by acre. So if you do, and which I've done in my analyses, if you look at the nutrient impacts per unit of output, so per pound of beef versus per acre, the results reverse. So in my analyses, a grass-fed system actually looked much better per acre for things like water quality impairment compared to something like dairy beef, which is a really intensive kind of corn-fed beef system. So you can look at them per acre and you get a much different.
Oh yeah, no, I see it when I walk into the dairy farms.
Yeah.
I mean, Gladstone, who was here earlier, is 1,400 cows. You know, he has a land base where he buys from, or grows corn is about 700 acres. And in a grass-based system in our climate, that would support maybe 500 head. So if you have 1,400 cows and it's all concentrated in 1 acre to live on, or you have 500 and they're spread over 500, it doesn't take research scientists to get to that conclusion. And so we had a couple more questions. Oh, sorry.
I was just going to add another piece to your question, which it's one of those things that farmers in Vermont are particularly conscious of and sort of always have at the forefront, because separate from climate change, separate from the more extreme events and higher precipitation and short bursts and what that means for it, we've also been looking at past events and how flushes from large events cause a lot of non-point source to become point source, right? And how does that end up in a body that is 12 miles wide, like Lake Champlain is? And what are the sort of trickle-down effects that you get from that, including things like algal blooms and so on. So I think it's very much on the forefront of a lot of farmers' minds in Vermont from a water quality perspective as well.
Question over here.
Hold on, there were other people first. Henry was there, and then the gentleman.
Okay,
whatever.
Go ahead.
Just don't want to forget about them.
Yeah. I'll move with it.
I appreciate you're urging us to define grazing. We also had a conversation here about, is regenerative agriculture different from sustainable agriculture? That seems to be a undefined word. I was also curious, 5 years ago actually, I got a soil test back and it was 22% organic matter. And I was like, sweet. And I was with Dr. Tom Morris out of University of Connecticut, and he said, that's not sweet. You're way overloading the soils with phosphorus, and phosphorus is soluble, and it's going to have all these detrimental impacts on the groundwater. Can there be too much soil carbon is another question that I have. And then finally, at lunch we had a conversation about othering and splitting in the ag community, and one's better than the other or worse. And you all kind of got into that a little bit up there with consumption, meat, whatever have you. So I'll invite us to look at how we manage the soil in all systems, be it zone tillage for vegetables, make no assumptions that grass-based agriculture is necessarily better or worse. How we are managing is the final thought I'll say.
So, too much soil carbon, huh? I haven't heard that one before, I must say. It's hard to know. You could have a lot of carbon and not have it be very high in nutrients. It really depends. I'd want to see the nutrient numbers with it. 22% is really high. I mean, that's classified as an organic soil then, right? The cutoff is 20%. So in terms of the stability of that carbon, I would be a little bit concerned because it's not going to be associated with minerals if it's that high. And so I'm not sure how stable it would be. And if it's not stable, then yeah, it could run off into aquatic systems. There could be nutrient release. But I really want to see the texture of it before I made a judgment call.
I could add, I'd also like to know how you sampled the soil, because we see a lot of anomalous results because folks sample their soils differently, and without a uniform protocol, it's hard to know. It's really hard to know how to interpret soil results. So that is a lot of organic matter, but it doesn't necessarily correlate with high phosphorus.
What depth did you sample?
4 inches.
So it was a typical 4 inches.
Yeah.
Wow, that's really high.
It was straight up composted contour that we've been adding year in and year out.
Well then, okay. So that is just an organic layer. And if it is not getting incorporated into your soil, then I would say that could definitely be a water quality issue. Yeah. So I might hold off from adding more and wait a couple years for it to get incorporated and then add some more.
So we're talking about climate here, and I'm wondering, I've heard talk about soil and sequestration, but I'm interested if you have any comments or awareness of the work of Walter Iena from Australia. He's a soil scientist and has become a climatologist as well. And he's pointing out, or he's promoting the idea that keeping more days of active growing plants on the ground in a year enhances, does two things. It has a cooling effect at ground level, and because the sun's heat is being absorbed and it's transpiring moisture and sending that heat up to the cloud level, and when it turns into cloud or raindrops, it throws away that heat, and it throws it away at a higher altitude where more of it escapes back into space. So there's two cooling factors there that he feels will cool things faster than greenhouse gases are currently warming. Any thoughts?
Well, the one thing I would say is that clearly the longer you have a growing plant in the ground, the more carbon you're capturing within that given year. And I am slightly familiar with his work, and he's focused on water, and carbon and water tend to be very closely coupled. So I think there's a lot of value in what he's putting forward. Yeah.
I will say that the effects of the cooling, there's the storing the carbon is like a global issue, but the cooling in terms of the plant cover is a much more local cooling effect, right? So one of them has global implications and one of them really has local implications. Well, it depends how much but to actually measure that cooling effect, you're going to see that in the vicinity of the plants. Yeah.
Right. I think what Henry's trying to say here is that there's a lot of local cycles that are all interconnected, and we're just not smart enough and don't have the technology to measure what it's actually doing yet.
So I'm not familiar with that work, but I will look it up when I'm done here, and that would be awesome. Because one of the biggest unknowns from an atmospheric perspective is the role of clouds, because it's the height of the cloud, it's the type of the cloud, and it's the thickness of the cloud, and how that interacts with the water vapor, the moisture, and everything else. So I'd be really, really curious to delve a little bit deeper and see exactly, like what types of clouds are involved here, because it's one of the biggest unknowns in the climate model still.
Just recently got the power to fix the starting model.
So I want to understand this a little more clearly in terms of the climate emergency, right? We have people around the world saying we have to change things really fast and really dramatically. And I'm not clear if what I'm hearing is this is about cows not being the villains, if properly raised, that they've been made out to be in the climate story, but also not the solution that many people have claimed they might be. Is this a significant drawdown strategy, at least in certain geographies? Maybe it's drier climates, maybe it's regenerating, debilitated grasslands in certain drier areas. Maybe we need dung beetles associated with that. I heard somebody once claim that was the magic elixir to pull all the carbon out of the atmosphere. And just related to this, in the slide you showed earlier, Nico, with the sequestration of 300 some odd tons of carbon in your soil, were you offsetting that by the amount of methane you estimated was produced? Or was that not in the calculation? So, curious where we stand.
In one of my slides, I took the liberty of paraphrasing Tansley's comment that humans are a particularly powerful biotic factor, and cows, livestock of all kinds, are a particularly powerful biotic factor. Consequently, they're a very powerful tool we can use in ecosystem management, including management of our ecosystems for enhanced carbon capture. That doesn't mean that's what we do, generally. In fact, we generally don't. But they are a tool, and a very powerful one, and about 50% of the world's land area is currently dominated by livestock grazing. So the question is, how do we affect land use change on those landscapes? Is it by eliminating livestock? That would probably be a serious mistake. So I think what we have to do is take our understanding of these systems and understanding of the role of livestock in those systems and apply it appropriately so that we actually are using livestock, just as we could ask the question, what is the role of large herbivores in the ecosystem? Why did these animals evolve? And Markleff and Lowenroth and others going back into the 1970s suggested this was an energy optimization strategy. This is how the ecosystem evolved because of available energy, unutilized energy, and these animals emerge over millennia, over eons of time, in response to available energy in the system. So it's really about, as I tried to show in my slides, the management of the flow of solar energy into our ecologies. Whether we do that for good or ill is, we do have the understanding to manage our systems appropriately. We don't have an economic or social structure that encourages that management. On the contrary, we have a very extractive economy and a very extractive agroecology. But that doesn't mean the processes aren't there and available for us to use, including that very powerful tool, which is the grazing animal, the ruminant.
So there have been a few high-level kind of global scale modeling analyses that try to answer this exact question, to understand not only for things like ruminant agriculture and grazing, but just kind of natural climate solutions. That's what goes under this umbrella. So things like reforestation, avoided deforestation, et cetera. And one study showed that we could, as a global community, probably get 30% of the way to the Paris climate targets through natural climate solutions. But the majority of this kind of what I would call technical mitigation potential, the majority of mitigation potential is available through forest-based strategies. So reforestation, avoided deforestation. In that analysis, improved grazing management and kind of ruminant system-related strategies were only contributing about 5% of that 30%. Now, this is, folks in the Marin Project are doing things at the frontier, so we don't have kind of, I would say, science is evolving all the time, and so maybe there's more potential, mitigation potential available if we have improved management, but we have to be really careful about applying, as we've been talking about, site-specific results to lots of different kinds of biomes. So those are kind of the best available estimates we have at a large scale now, and hopefully there's more room for mitigation from natural
Nicole?
solutions too. Yeah.
So, does it have to be pasture or forest? Where does silviculture play a role here?
So silviculture was part of, was also included in that portfolio, as was just putting trees on cropland, like incorporating trees into cropland. Agroforestry, et cetera. So there was a whole suite of mitigation, potential mitigation opportunities. Yeah.
There's, has anyone here heard of the 4 per Mill initiative?
Yes.
So this is at COP21 in Paris, the last conference of parties about climate. I guess this was put forth by the French government. It's this 4 per Mill initiative, and it's the idea that if we could increase soil carbon by 0.4% per year globally, that we could actually mitigate entirely for fossil fuel emissions. Now this is super, super pie in the sky, and subsequent analyses have showed it might be possible with improved management on agricultural lands to take care of 20 to 35% of our current emissions. But that is, I mean, that paper has been roundly criticized as being way too rosy. But that means best case scenario for improved management, and so improved management just like, it could be going from a tilled system to no-till, or from crops to a grazing system, or from grazing system to forest. Any of those, combine them all together in terms of all the land we have in agriculture, it's about 20 to 30%. So it's still not enough to solve our problem, even in a best case scenario. It could be enough to slow things down, but the bottom line is this is not the solution to climate change. It can't be. And there's worthy reasons to be doing this. Again, as I said, there's really worthy reasons to be doing this, but it's not going to save us. It won't.
So let's take a few questions and then have people respond. Yeah. So 1, 2, and 3, and then Hannah. Yeah.
I just have a quick question. Just I'm a little confused, and I was hoping that we could all agree on like the facts and the assumptions. I think I heard you say twice today that agriculture is responsible for 40% of carbon emissions, and the number I always hear is 9%, which is from the US EPA. And so I just was hoping that people could comment on that, because that's a huge difference.
Yeah, I think the confusion there is, if I could just say a quick thing before the next thing, is that this is a historical perspective. So over the last 150 years, we've continuously emitted carbon through agriculture. Currently, the emissions are 10%.
Can't hear you.
9 or 10% currently, and we can argue about where that is exactly is, but we have this long arc of having emitted stuff that isn't being done. But we started plowing and tillage on a large scale in the 1840s. And since then, we've released so much carbon. You know, the topsoil in the Dakotas was 12 feet deep, that's 12 inches deep. That's all up there, or in the Gulf of Mexico.
So can I also answer? Can I also answer?
Well, I want to get just let the audience feed and then back.
And then back?
Yeah.
Okay, great.
So can man-made wetlands help, like man-made wetlands specifically on agricultural sites, can that help with climate change, like mitigate? Oh, sorry, can you hear me now?
The question was, do you want to repeat the question?
Yeah, can man-made wetlands on agricultural sites help store carbon like better and mitigate with climate change?
Well, I don't know if I think we're not allowed to answer.
I just have more of a comment that I want to caution us about. I think there are two different questions here. Physical potential of agricultural soils and systems to sequester carbon and be part of. I don't think it's a solution alone. I don't think most people are putting it out that way. But I don't think this is always a science technical question. This is what Jeff alluded to, which is an economic social question if we're going to organize ourselves here to do this. Because I think we see performance on agricultural systems actually exceed the assumptions that we've seen in studies, and we see some that do very poorly. The question is a political, economic, and social question. I don't think we need to continue, we can have debates around the technical potential, but if we don't get it on the ground, we then don't challenge the assumptions that come out in these studies, which are basically on a paucity of action that we're taking. So I just want to caution us about who we're asking feasibility questions of. And I'm not trying to criticize scientists, but typically a lot of scientists who do technical work are asked about feasibility, and that's actually a practice question. And we need to have folks in the room who've done that start to answer the possibility questions of scaling this work. So just want to put that caution out there.
Okay, now, do you want to take some more?
I think we can.
Yeah, we got time, so we'll let the audience speak back for a while, guys. Okay?
Yeah.
Take a break.
Thank you. I'm Dr. Lynn Kahn. I'm a psychologist, not a farmer, though I'm an honorary member of Farm Women United and proud to say that. I, most importantly, got so angry about so many things that in 2016 I ran as an independent candidate for president, and in 2018 ran as a third-party candidate for Congress in upstate New York, where I really started to understand the dairy farm issues. So I want to add to, let's get practical, it is urgent, and say you have to bring the political piece into this too, and the white papers, interdisciplinary stuff. You have to include information for political candidates so that we're stronger when we get asked questions about issues we don't really understand. Or run for office. Everybody in this room ought to think about running for office, or finding somebody that they will support in running for office. So these questions and these issues and your brilliance, I've learned so much today. There's an enormous amount of wisdom in this room, so that your wisdom gets out into the public dialogue, and it forces, because you need to be on the debate stage in a political race. And that forces the media, where's the media? To come and pay attention to what you're having to say. And I need to hear it. I mean, I'll help anybody in this room who wants to run for office. I need to hear it in plain language so that I have an article due in 2 weeks, I'm gonna talk about this stuff, but I need it in plain language so I can educate people. So along with your white papers and peer-reviewed journal articles, which I know are important, what's your press release? How are you going to say this in one page? How are you going to say this in letters to the editor? Or how about candidate forums? Demand that candidates for office come to events like this. They can't turn you down, really, though they did turn down Farm Women United. So that you're forcing them to listen to what you're saying and what the issues are, and you do this kind of agreeing on definitions and how you're defining the issues and how you're defining the solutions. And there's no time left. Economically, socially, environmentally, hunger, criminal justice, we've run out of time. There's no time left. So please include the political in your conversations.
Thank you, Dr. Kahn.
So I kind of wanted to bring this back to some of the prior panels. On the last panel, they talked about the externalities, the benefits that farmers provide. And I know recently in Australia started a program in paying farmers for the benefits that they provide. I'm wondering, are we ready for that here in the United States? And if not, what do we need to get there?
Thank you. That's great. One more? Do you want to do one more? Sure.
So there's a really interesting tension, I think, in this discussion and larger discussions about farms about, is the natural system kind of bad, or Jeff, you're talking about like managing and sort of implying that humans can step in and kind of fix this and be the active agents, versus the idea that somehow humans are the ones that have screwed it up and maybe we should just kind of let the, not let the natural systems kind of take over, but that it's, you know, who should be instigating this. And agriculture is obviously right smack in the middle of that question, but it seems like we may need some kind of larger consensus about the role of the human within these systems than I think we have across agriculture at the moment.
That's great. Great question. So wetlands, human system interactions.
Thinking politically.
Thinking politically, practical, and sort of bringing it into the whole context of what can we do.
Wetlands is really quick. So wetlands, especially freshwater wetlands, have a lot of other greenhouse gas emissions. So the methane emissions of a freshwater wetland would, yes, they would store carbon, but it would be a net negative or net positive of greenhouse gases to the atmosphere because of the methane emissions. However, the wetlands do a great job of solving nutrient problems. So there's reasons to have them.
I will answer the 9% to 40% difference just really quickly. So the 40% number cited is usually a global scale contribution of agriculture and the entire food system from a life cycle perspective. So this includes not just the direct emissions from agriculture, it also includes all the upstream fossil fuel use for tractors and land clearing, etc. So that's the big picture. And deliveries, all that kind of stuff, right? It's the whole supply chain. Whereas the 9% that USDA puts out, those are the direct emissions from agriculture. So just really farming and land use related field emissions, not the whole supply chain. That's the difference that you'll see.
Yeah, and the big point is there's food waste. It's one of the huge unknown carbon contributors. I think I read somewhere if food waste was its own country, it would be the third largest carbon emission source on the planet.
I'd like to touch on a couple of those questions. Actually, just going back to soils versus forests. California's forests at this time are net emitters of carbon. Anybody west of the Rockies knows our forests are not a reliable carbon sink. They have a nasty tendency to burn up and put that carbon right back into the atmosphere that it came from. So I think our soils are a better bet when we look at, not to say that forests aren't important, because they clearly are critically important, but when we look at where carbon resides in the biosphere, soils in fact are the second largest carbon pool. So it tells us something about where organic carbon has tended to accumulate over millennia of time, and it's not our forests.
I mean, forest soils store more carbon than grassland soils.
Ooh, interesting.
In some systems, I would agree with you.
Getting overall in temperate systems, for sure.
Great. So you can see there's some debate here. And then I touch on the human question and the management. Are managed systems superior to, quote, natural systems? What is the role of the human in this global ecosystem? And I think we've probably been asking ourselves that since we started thinking, right? My sense is at this point, with 7.5 billion and counting, we probably need to be thinking very hard about what is our role and how can we begin to participate constructively in the trajectory of the biosphere, since we've done such a great job of showing that we have an enormous capacity to influence the biosphere in a very negative way. perhaps we have just as much power and potential to do the opposite. And that, again, I think is sort of the promise of the feedback concept, that it kind of points a way forward if we should choose to actually engage in the processes that we're talking about.
So I'll take one question about the roll-up of humans, and I wanted to raise it. I'm not sure if we've heard it today yet, but it's a climate justice piece in all of this that we need to make sure that we keep in mind as we move forward from all different levels, all different populations and communities and vulnerabilities, but also from a sort of emerging nation versus emerged nation perspective, and how does that discussion sort of play out, so that there's one piece in that. And then I also wanted to respond to your question in terms of communication, because I give about 20-something talks per year, and a lot of it are to things like school kid groups, but also to retired folks. And I think there's a lot of opportunity there in terms of speaking clearly and speaking cleanly, and sort of getting people the information that they need to make the choices that they need, or to make the sort of actions that they need. And so I wholeheartedly echo what you have said about that. And in Vermont, we're really, really lucky that we have folks like Patrick Leahy, Bernie Sanders, and Peter Welch, who will put the money where the willpower is to help enable some of those programs that are sort of bubbling up from the ground level. And so there is that piece that we can have the sort of political piece merge with the grassroots piece from a student perspective, but also from a retired perspective.
So yeah, to talk about the benefits of farmers, like are we willing to pay? I mean, yeah, it goes way beyond soil carbon, right? It's part of the culture here, and especially in Vermont. And I think losing what's happening to the dairies and everything, and the closing down of these small family dairies is affecting our landscape. It's affecting how I think this region even sees itself. So yeah, from that perspective, I think to think about the value of grazing systems, we do have to think really broadly and into our culture.
Yeah, not only that, we often forget that there's appropriate application of different systems to different geography. We plainly don't have flat ground in New England, but what we have, we saw that, Tom, I think you showed that early on, what is cropland and what is pasture land and what is forest land in New England, and we just have no choice. I mean, we can graze cows on flat ground, but that's a pretty stupid thing to do. We have lots of hillsides that we get $8 billion worth of revenue in the state of Vermont. Is it billion or million? No, I think it's billion. Of tourist and agritourism and stuff like that. And that depends on our landscape looking and functioning a certain way.
As someone who started to study old fields in Vermont, and these are abandoned pastures and ag lands, I can say that, and they're maintained, so in Vermont, New Hampshire, those are now maintained for their view, to have that look, right?
Right.
But to just mow a field to keep it looking like it's ag is actually a really poor use from it. And from a carbon storage standpoint, it doesn't store carbon nearly as much as it would if we actually had animals on it.
Yeah, thank you.
Right here.
Yes.
Hi, thank you.
Seth.
Thanks. Hi everyone, my name is Seth Itzkan, and I'm here with my colleague Carl Tiedemann, and we're the co-founders and co-directors of a group called Soil for Climate. So this is the right session for us to be at, and I want to thank Matt for putting together this extraordinary event. We sort of have a saying in our organization, just a funny thing. It says, it doesn't matter what the question is, the answer is soil. Right? So just kind of think about it like that. Like, if you're building soil carbon, you're doing the right thing for whatever the situation. If it's an agricultural situation, then you're doing something right with agriculture. If it's a grazing situation, then you're doing something right with grazing. If you want the forest to come back, then that's appropriate for that. You know, there's no one sort of, right answer for every situation, although for us the right answer is soil carbon. Like, if the soil carbon's getting better, then somehow you're doing the right thing. So that's just our sort of general rule of thumb. Legislation, you know, there's healthy soils legislation that's been proposed now in 9 states just in 2019. Massachusetts, Vermont, New Mexico, California. So you're seeing healthy soils legislation, and so people are going to say, well, what's healthy soil? And how do you verify it, right? So it's getting really like matter of fact. And in a lot of places where there's grazing done right, the soil will be better than where there's, you know, commercial agriculture. I think a big player is going to be the insurance industry, actually. I think farm insurance, crop insurance, flood insurance, fire insurance, they're going to start, before they start underwriting policies, they're going to say, well, what are you doing about your soil? So I think that's going to be a huge factor in this. Ironically, the insurance industries might come to the rescue in this situation. Anyway, so that was just what I wanted to say about that. Thank you.
Any other questions on the floor?
So I want to be provocative.
Good.
And just because I noticed the tension between Jeff and Caitlin. So, but let me observe it. Let me observe it. I enjoyed it. I enjoyed the last panel when there was tension. This is good. Tension's good.
I would just say I think the tension is more of an east-west perspective than anything else.
Well, so let me expose that a little bit by saying, okay, so one of the things that you were saying is that wetter climates, you have less return from in restorative, regenerative grazing, right? And so one of the things that Jeff's saying is, you know, the forests in the West, and California in particular, are carbon emitters, and you're referring to the tragic things that have happened recently of forest fires, right? So that's what you're referring to. So this is kind of an argument against my own interest, because I am farming here, right? And definitely Nico's interest. But if the return on intensive grazing is less in wet climates, and we're in a wet climate, then should we be doing more to restore and defend and maybe expand forest in New England versus the kind of grazing that we're practicing? Is it an argument where, like you said, it matters where you're studying it? So, yeah. So
can I add to that a little bit to flesh this out? So, holistic management system that was refined by Alan Savory, who some of you might have heard of, defines some climates as brittle and others as non-brittle. I think the point is that we already have very productive systems here, and that our carbon sequestration process and our biological processes are already working way better than they do in arid climates. So it's not that this is a worse climate to have the agriculture. For us, it's more appropriate land use. Out west, it's a matter of survival in getting the groundwater tables restored that have been severely abused by pumping water to produce almond milk. And so I think the issue is a little bit, it's a little bit different twist on the same topic. And I would be really curious to see how we can reframe the conversation about what is the appropriate use of our landscape for our region, for our food and nutrition needs, because this is really how it all comes together. Because it does not make sense to irrigate desert land in California with subsidized water and then spend millions mitigating the climate effects from that by reestablishing groundwater tables and so forth. And directly competing with the imported dairy products that come from that region where our dairy farms are going bankrupt. That's where it really gets me, because this is a social issue. Thank you.
The approach we've taken with the Marine Carbon Project and the Carbon Cycle Institute and our work in California is we will work with any farmer who wants to work with us. And I don't care if they're a beef producer or an almond producer or a wine producer or a vegetable crop producer. I want to have a conversation with them about the role of carbon in their agricultural ecosystem and how they can increase the capture of carbon on that working landscape. I'm not going to dictate to them what they're going to do with their land, but we're going to have a deep dive conversation about the role of carbon in that agricultural ecosystem. So I don't think this is an either or conversation at all. It's about understanding our relationship to the carbon cycle and managing our agricultural ecosystems in accordance with that, particularly in the context that we're having this conversation, which is catastrophic climate change. So there's a lot of flexibility here. We would, be really happy to be able to establish agroforestry systems in California as easily as it can be done here. And a lot of folks are trying, and successfully, but we have challenges in California in integrating trees into our livestock systems and even our cropping systems. So again, this should be an all hands on deck, all strategies available, applied to all the systems that we're all working with. So.
I was just going to say, in terms of opportunities for the region, so the work that I've done both on dairy beef and grass-fed beef, I'm going to say something that might sound crazy to those of you who graze beef animals. So I think because dairy beef actually happens to be a really low carbon source of beef, but we have this issue of concentrating nutrients in the environment with intensive production systems. I think there's actually an opportunity there to combine what's great from beef breed grass-fed systems and dairy breed beef systems by not just grazing Holstein calves, because that's really hard and doesn't go very well for most people just because of their genetics, but by actually incorporating grass-fed beef genetics into some of the dairy calves coming off of dairy farms, so that you have cross calves that are dairy and beef, providing a better revenue stream for dairies who are struggling because those animals could potentially be grazed in a grass-based system. So it's kind of a wild idea. I don't know that anybody's actually trying that.
Yes, the entire European continent has been doing this for hundreds of years.
Yeah, has been doing dairy beef crosses. Yeah, and it's kind of, and New Zealand. So it's kind of wild to me that nobody is doing it here that I know of.
No,
Yeah.
that's not it. It's two different philosophical camps. It's like motorcycle and riders and bike riders. Same two-wheel transportation, totally different concepts.
But anyway, I think that's a way to take kind of our strengths and do the real work of sustainability and navigating trade-offs and thinking about how we create new and exciting systems that are good for New England. So.
I love that idea.
I was going to say, one thing in terms of the forest question, yes, forests are better at storing carbon, but in terms of the ag land here in New England, if we can't maintain it as ag land, is it really going to go back to forests? That's not the use, it's likely not the use it's going to go into. It's going to go into pavement. Solar panels is another whole other thing. But I don't think we can say, oh, if I'll go back to forests from a carbon perspective, maybe that'd be better. But that's not what would happen. And we have to think of it from this cultural perspective and this economic perspective as well.
Yeah, we've been hearing for the last 10 or 15 minutes that technical questions are always political and economic. And there's an economic issue at stake here that I don't think has been raised and ought to be, and I want to hear what you say about it. And that is, if we take the idea that any kind of soil improvement is good, right, and it should just be done for their own sake, which I can agree with, that's fine. The problem comes in is that so much farmland is leased. And so those who will capture that good are the landowners and not the farmers through increased rents and other mechanisms. Right? It's precisely a disincentive towards capital improvement on farms when you're leasing and so forth, because that value will be captured by the landowners. How do we think about these issues that any kind of soil improvement is good when those who are doing the work of it are not the ones who are necessarily benefiting from it?
Abe, do you want to answer that one?
We stumped the panel. Don did.
But that is the question, right? How do we begin to societally value the work? And I think Carbon Cycle's working on that with policy in California. I know there are folks here. We had some conversations over lunch, also asking the same questions. Abe's been working on how do you actually measure these benefits, and hopefully one of these days it's going to hit the jackpot on that. But that is the fundamental question. I certainly don't have an answer to.
Well, if I may, Tori summed this up earlier really, really well. We need to develop solid practices, and we're, in some ways, really at the beginning of doing that, so that we actually know what is the appropriate practice for every particular climate zone. And farmers, and that's the work that I do with Vermont Grass Farmers Association, that the Extension Services are doing, is on-the-ground technical work of observational feedback. This is working because we've increased plant density by a factor 2.5 over the last 2 years on our land. Whatever we're doing is working, otherwise this wouldn't be working. It doesn't really matter how. That's for other people to answer, and that's great. That needs to happen. But quite frankly, the research is about 10 years behind the practices. So they have some scientists some catching up to do, and rapidly so, because once we have the practices and we can measure what we're doing in scientific terms, then we can talk about monetizing that if we still want a capitalist system to do that. Last question?
Actually, it's not so much a question, it's sort of a response to your question or a comment to your question. You're hitting on our deep societal problem, really. This is what the issue is around affordable housing. Why would we want to fix something if the landlord is going to be reaping the benefit? And it's, we keep being asked, we got to do intensive agriculture because that's the only way we can feed the world. We keep asking the wrong questions. And I think this is one of those situations where we're asking the wrong question again, which is, why do we do this when I don't get to reap the benefit of it, when we really know part of the problem is, why did the land get taken away from the people to begin with? So that the incentive to take it into the care that they know what care they have to apply to it is no longer there. Why did land get taken away? Why did seeds get taken away? Why did fishing rights get taken away? So this is sort of the underpinning of all the issues we're talking about here. We have held land, cows, people in servitude, really, and now we're reaping the problems associated with it. So in order to deal with climate change, in order to deal with food security, food sovereignty, we got to go back to restoring basic rights to anybody who grows our food, catches our food, eats our food, so that those incentives are inherent in how we practice, not something that we may want to incentivize through some program, government program or corporate program. This has to return to be part of our DNA.
Thank you so much.
That's why an organization like Food First says that reparations has to be a part of the conversation, right? So, but we're at the end. Right?
Yes, we're at the end. Time's up. Thank you so much, panelists. That was very, very good.
So what will we do next?